Hi everybody, my name is Maurício Shimabukuro and I am a postdoc at Nordsee in the University of Southern Denmark. My talk today will be about whale-fowl fauna distribution, highlighting the presence of shared species between ocean basins and cognate environments. Whale-fowls are important environments in deep sea due to the large input of organic matter, improving the food availability to deep sea fauna along at least 3 successional stages. Because of the large organic input, a sulfophilic stage can happen, and the whale-fowl community is sustained mainly by the chemosynthetic production, resembling those one from hydrothermal vents and seeps. As whale-fowls can host some species from vents and seeps, was hypothesized that they can act as stepping stones for dispersion among different chemosynthesis-based ecosystems. Around the world, only few whale-fowls have been studied, and most of them in the Northeast Pacific. Here, I will present a brief summary about the studies in Southwest Atlantic. Comparing Southwest Atlantic whale-fowls with others around the world, we found some shared species between ocean basins. The first that I will present here is the bone-eating worm Osedax frankpresi, present in Northeast Pacific and Southwest Atlantic. The CO1 divergence between both populations is around 3%, and according to haplotype network and analysis of molecular variants, both populations are segregated, probably due to the large distance between them. When we look to another annelid worm with interbasin distribution, Cirsoy balenophila, we found that this species is in fact a species complex with at least 4 different species. However, Cirsoy balenophila stricto sensu is present in Northeast Pacific and Southwest Atlantic, and the divergence between them is around 1%. In Southwest Atlantic, we found other 2 Cirsoy species with wide distribution, Cirsoy syricus, that is found in whale-fowls from Northeast Pacific and Southwest Atlantic, and Cirsoy maximianum, that is present in whale-fowls from Southwest Atlantic and vents from Mid-Cayman Breeding Center. This finding is consistent with the hypothesis of whale-fowls acting as a stepping stone for dispersion. Another example supporting this idea is the presence of Alvinocaris muriculus shrimp in whale-fowls from Southwest Atlantic. This shrimp was previously reported in seeps from West Africa and Gulf of Mexico, as well as in vents from Mid-Atlantic region. For the first time was reported inhabiting whale-fowls. Haplotype network and molecular variants indicate segregation between populations from the Atlantic equatorial belt and Southwest Atlantic. One possible explanation is that occurred previous expansion events from Atlantic equatorial belt to Southwest Atlantic, with later loss of connection. However, the low number of individuals in Gulf of Mexico, Mid-Atlantic ridge vents, as well as in Southwest Atlantic, could inflate the fixation index value. For this reason, more studies, increasing number of individuals, and adding possible intermediate population should be conducted to clarify if Southwest Atlantic population are connected or not to the populations from Atlantic equatorial belt. In summary, the first studies in Southwest Atlantic show the resemblance between whale-fowls from different ocean basins. It is feasible that whale-fowls community are not divided in different biogeographic provinces, as hydrothermal vents are. Other regions should be studied better to understand it, but it is known that for at least 6 Osedax species, they have wide distribution in different ocean basins. Also studying a similar environment, Saed and collaborators found that 6 species of woodfalls from Southwest Atlantic is also present in woodfalls from Northwest Atlantic, Caribbean Sea, and Northeast Pacific. As more studies have been focusing in deep sea whale falls, more shared species have been found among whale falls, vents, and seeps, supporting the hypothesis of whale falls acting as a stepping stone for dispersion, at least for part of the vent and seep fauna. Thank you very much for your attention.